Now let us look at the fifth problem. That is, a set A has m elements and set B has n elements. So you go to, if the total number of subsets of A is 112 more than total number of subsets of B, then you got to find what is m into n. Okay, so these are the choices, and we'll see the best choice which we have. Okay, which we get. Okay, let us see that. So we have been given that a a subset, the total number of subsets of A is 112 more than that of total number of subsets of B. So suppose if I consider number of elements of a set A as m elements, then number of elements in that will be n of A, which is m, and a set B, which has n elements, so which will be n of B, which is n. So now if you look at a subset of a set A will be 2 to the power of n. These are the subsets, and for this is 2 to the power of n. Now Now, how would we relate with that? Okay, so subset of A, that is 2 to the power of m, is equal to 112 more than subset of B. So 2 to the power of n plus 112. So when you get this equation. Now let us put all uh, this term on the left hand side, 2 to the power of m minus 2 to the power of n. So 112, uh, uh, when you try to simplify it, so you get 16 into 7. 16 multiplies 7 is 112. So 16 can be written as 2 to the power of 4. Okay, 7 can be written as 2 to the power of 8 minus 1. Okay, so this is 16 into 7. Okay, so this I can take 2 to the power of n, right? 2 to the power of m minus n minus 1. So this is, as you can see here, so 2 to the power of 4 into 2 to the power of 8 minus 1. Now compare this here. So you get n as 4 when you compare with this with this. So n as 4. M minus n, okay, m minus n is 2 to the power of 3, right? 3, sorry, 2 to the power of 3 is 8. So 7, which is 2 cube minus 1, which is 7, right? So this is 3, right? So m minus n, so this will result to m as 7. So in the question it was asked, what is m multiplied n? So that is 7 multiplied 4, which is equal to 28, is the best answer. Now let us look at the sixth. Now let us look at the sixth question here. So if you see this here, a set A is this, and set B is this. Okay. So what are the number of subsets of the set? Okay, A multiplied B. So let us see that. Okay. Now, if you look at the set A, right? So A, which is 2 to the power of x plus 2, right? Okay, multiplied x square minus 5x plus 6 is equal to 1. Okay. Now, if you look at this, so I can write 1 as 2 to the power of 0. So I can compare this with respect to this. right? So that is 2 to the power of x plus 2, which is 2 to the power of 0. And this x square minus 5x plus 6, this is a quadratic equation which is equated to 0. So here, if I look at this, right? So x plus 2 will be 0 or x is minus 2. And for this, you get the factors as x minus 2 and x minus 3, which is equal to 0, or x as 2 comma 3. Now, if you combine these two, right? So, so you get the set A, which has got the elements minus 2, 2, and 3. So number of elements of a set A is 3. Okay. Now let us look at set B, which is defined as like this. That is under minus 3 less than 2x minus 1 less than 9. So, so this will be 1 minus 3 less than 2x less than 9 plus 1 when you add. So this becomes minus 2 less than 2x less than 10 when you divide it by 5. So this is 1 less than x less than 5. So here uh, the elements, so that is minus 1, 0, 1, 2, 3, 4, 5. So this x belongs to that open interval which is minus 1 and 5. So minus 1 and 5. So you have the elements inside this is 0, 1, 2, 3, and 4. So we got 5 elements in this. So what we require is a multiplied b, which is subsets. So 2 to the power of m into n, which is 2 to the power of 15. Now let us look at seventh problem. So here, which is z, which is a complex number. So we have to compute this, and this is an inequality, right? Also given as inequality. Let us check this. So let us solve this problem. So we know z is x plus iy, which is a complex number. So mod z will be a square root of x square plus y square, right? And we know the real part of z will be x. This is a real part of z. Okay. So given that that is mod of z minus real part of z um, is less than or equal to 1, which is given. Okay. So let us write down. So square root of x square plus y square minus x less than or equal to 1. Okay. So bring on to the right hand side. So this will be x square plus y square less than or equal to 1 plus x. Now squaring this on both sides. So uh, what we get is x square plus y square is less than or equal to 1 plus x whole square. So now this is x square plus y square less than or equal to x square plus 1 plus 2x. So you can cancel these terms, right? So y square is less than or equal to 1 plus 2x, or further you can write as y square is less than or equal to 2 times x plus 1 by 2. So this is the best possible answer. So now let us look at the next problem when you have mod of z plus z is equal to x plus 1, right? So let us find the solution for this. So now that is so from the previous question, we've already seen that z is x plus iy and mod z is square root of x square plus y square. Okay, so using those, right? So given that mod of z plus z is equal to 3 plus I, mod of z which is a square root of x square plus y square, write this down, and z which is x plus iy, which is equal to 3 plus I. What you can notice comparing this in real with and imaginary. So you can find that y is equal to 1 when comparing this. So y will be 1. So and this is x square plus y square plus x is equal to 3, right? So take this. So this will be x square plus y square is equal to 3 minus x. And squaring this on both sides, what you get is x square plus y square 3 minus x whole square, right? And when you simplify this, you get minus uh, and substituting x is equal to 1. Okay, we'll substitute that also. So x square plus 1 is equal to x square plus 9 minus 6x. So these terms gets cancelled. So you get minus 8 is equal to minus 6x, uh, which x is 4 by 3. So now we got what is x and what is y. So we need what is mod of z. So z which is 4 by 3 plus I, right? So mod z will be square root of this is 4 square, which is 16, and 3 square, which is 9. This is 1. So this is root 25 by 9, right? So which is 5 by 3 is the possible, best possible answer. Now let us look at next problem. We have given a lambda, which is the ratio of the roots of the quadratic equation, which is given for this. So what will be the least value? Okay, let us find the solution for this. Okay, so let us see that. Okay, so uh, as we have seen that lambda is equal to the ratio of the roots. Let alpha and beta be the roots. So alpha by beta. So this is the ratio here. Okay. Now as we know that sum of the roots is alpha plus beta, which is equal to minus b by a, which is the formula, and the product, which is alpha into beta, is c by a. Okay, please remember this. Okay, for the general equation ax square plus bx plus c is equal to 0, right? Now we are being given that 3m square x square plus m into m minus 4 into x plus 2 is equal to 0. So you can find here this as a and this as b and this as the constant c. So let us put down. So alpha plus beta is equal to minus of um, m into m minus 4 divided by uh, 3m square, and alpha into beta, that is a product, which is 2 by 3m square, right? So um, we are being given that lambda plus 1 by lambda is equal to 1. So we already know what is lambda, which is the ratio of the roots of the quadratic equation, which is alpha by beta. Let us write down alpha by beta, and the reciprocal of lambda is 1 by lambda, which is beta by alpha, which is equal to this, is equal to 1. So this is alpha square plus beta square is equal to alpha beta. Now, we have been given the alpha plus beta as this and alpha beta. So, what we need to write is alpha beta whole square. Okay. So, I have subtracted it. So, with minus 2 alpha. So, when you get on the right hand side, it is 3 alpha beta. Okay. So, let us substitute alpha plus beta and alpha multiplied beta. So, let us see that. So alpha plus beta whole square will be minus m into minus m minus 4 by 3m square whole square is equal to 3 times alpha beta, which is 2 by 3m square. Okay, so this is m square into m minus 4 whole square divided by this is 3m square multiplied 3m square. So I can simplify uh, the terms, right? So this is 6 divided by 3m square. So you can cancel this out, right? And this term and these terms you can multiply if it goes to the other side. So you get m minus 4 whole square, which is equal to 18. Okay, further simplifying, you get m square minus 8m uh, minus 2 is equal to 0. So when you find the roots of this equation, m is 4 plus or minus 3 root 2. And in the question, it was asked what is the least value of m, right? So the least value of m will be 4 minus 3 root 2. So this is your answer. So let us look at another problem. The root of this equation is given like this, which lies on the curve, right? So z is a complex number, right? So let us see the best possible answer for this. Okay, so let us see that. Okay, so what we have here, uh, as we know that z, which is x plus iy. Now the roots of this has been given. So I'll write in the terms of alpha and beta. So z is alpha plus I beta. Okay. So given that x square plus bx plus 45 is equal to 0. So now if you have alpha plus I beta as one root, the conjugate will be alpha minus I beta. Now the sum, okay, sum is alpha plus beta. So this you consider as one root and this as another root. So uh, as we have seen in the previous problem, alpha plus beta, it is alpha plus I beta. This is a complex number and plus alpha minus I beta. So this is minus b by a. So as you can see here, a in this, a is 1, b uh, is b, right? And c is 45. So minus b by a is minus b by a, which is 1. Okay. So sum you get as 2 alpha, 2 alpha is equal to minus b. Okay. or alpha is equal to minus b by 2. Got this result. Keep this result. And now the product. Product is these two roots you multiply, that is alpha and beta. Okay. So this will be alpha plus I beta multiplied alpha minus I beta, which is equal to C by A, which is 45. So this is alpha square, I square. We know that I square is minus 1. Okay. So alpha square plus beta square is equal to 40. Okay. Keep this equation 2. Now, in the given problem, mod of z plus 1 is equal to 2 root 10. Okay. So z is alpha plus I beta plus 1 is equal to 2 root 10. So bring on the real terms. Alpha plus 1 I beta is equal to 2 root 10. Now, mod of z is square root of x square plus y square. So here this implies square root of alpha plus 1 whole square plus beta square is equal to 2 root 10. Okay. Further, let us simplify. So as you notice that we had square root of alpha plus 1 whole square plus beta square, which is equal to 2 root 10. Right? Squaring on both the sides of the equation. So you get alpha plus 1 whole square plus beta square, which is equal to this is whole square. This will be 40. Okay. So let us substitute what is alpha minus b by 2 and alpha square plus beta square as 45. So this is alpha square plus beta square plus 2 alpha plus 1 is equal to 50, or this is 45 plus 2 into minus b by 2 plus 1 is equal to 40, or we simplify this, minus b is equal to minus 6, or b is equal to 6. So let us check each and every result when you find all these results. So b square plus b is equal to 12. No, it is not working out. So let us see the next one. B square minus b, is it 30? So yeah, it is 30. So this is the best possible answer.